Hi all, my name is Dhruv Sharma and I welcome you all on our next session on setting up Get VPN using multicast as a mechanism. So I highly recommend my viewers to go through the videos on setting up Get VPN using unicast as a mechanism before you start with this session, because setting up unicast as a the communication mechanism is a prerequisite. So on that note, let's jump in. So Get VPN stands for Group Encryption Internal, and we're going to configure it in our lab and review the building blocks in this session. So the session is divided into three parts. First, to review the building blocks of Get VPN, and the second will be review the implementation steps on the key server and the group members, and finally some lab fun. We will be using this network topology in our session today, where we have one key server on the top and two group members. So we'll be configuring most of the settings on the key server, like crypto ACL and all sort of stuffs, and that will be pushed down to the group members. So a brief overview about what's a Get VPN is basically, before we get into that, let's discuss about what's IPsec VPN is. An IPsec VPN is an industry accepted VPN solution where two parties each wants to communicate over the network, and we use ESP as an encryption header to encapsulate the interesting traffic. And in IPsec VPN, what it does, it adds a duplicate or it's not duplicate, a new IP header outside ESP. What I mean, for example, the two routers are over the network and they're trying to protect network X and network Y, which are the original IP packets. With IPsec VPN, ESP will encapsulate the traffic and add a new IP header outside. So anyone who is sniffing on this network cannot see whether it is X and Y who are trying to communicate. But whereas in Get VPN, it ensures that the private address range is reserved. So a IP packet is basically copied out to the external header, and we can see the IP addresses which IP addresses are trying to communicate over the network. So this makes Get VPN usable only for private LAN, or maybe you can use MPLS as well. So just want to, before we crack on with the implementation, let's see what's the difference between why we use multicast and unicast mode. So basically, the only advantage of using multicast mode is that it is robust and is more scalable. But with unicast mode, it's not. So why it does? Because in unicast mode, when the lifetime of this VPN expires and key server sends a rekey messages back to the group members, with unicast mode, the group members have to send an acknowledgement back. But in multicast mode, when the key server sends a rekey messages back to the group member, the group members are not supposed to send any acknowledgement back with multicast mode. Key server setup. So let's get into implementation of how we have to configure our key servers. So we can achieve the configuration of key server in just 3 simple steps. So I will bring up the topology so that we can easily correlate it to what we are doing. So this is the topology where first step is to configure VPN configuration over our KS. So in that case, we configure the phase 1 parameters, phase 2 parameters, defining the transform sets, and mapping the transform sets into the IPsec profile. We name the IPsec profile as key1 profile. We even define the crypto ACL. We call it as Barbie. So what happens is the crypto ACL is nothing but the interesting traffic back on the group 1, because key server doesn't participate in the real communication. No traffic is going. Suppose a group 1 is trying to send a traffic to group 2 server, it doesn't go via this method. No, it doesn't. It directly talks to oops, pardon me. It basically directly communicate over the network. So this setting of the crypto ACL will be pushed directly from the key server back to its clients. That's why we have created a crypto ACL 10.10.network, because the interesting traffic, as we can see in the topology, is 10.10.10 and 10.10.10.10. Pretty standard, right? Secondly, we have to, in step 2, we have to configure multicast configuration, because in this mode we are using multicast as an exchange mechanism. This is a very standard command which we have to use to enable multicast as a routing as an exchange mechanism, and we have to enable IPPIM dense mode. These two are standard configuration which we have to push to ensure that multicast routing mechanism works. So a quick overview about PIM. PIM basically stands for protocol independent multicast. So it's PIM, and various flavors of PIM are available, like PIM in sparse mode, PIM in dense mode, and bidirectional PIM and PIM source. I will recommend all our viewers to go through a Wikipedia page. There's a wiki article that talks about what are PIM various modes are and what are the differences in that. But in PIM dense mode, if I give you just for the brief overview about this scenario in dense mode, basically a router try to send a multicast update back to the clients, and this router, the ISP in our case, will going to, since we will be also be configuring it into multicast, it will flood the packet out of all the interfaces. So again, this router KS will going to push the configuration, push the multicast configuration in IPPIM dense mode to this router, and this router will flood the packet out of its all interfaces. But it comes up with the catch. The catch is this router will basically uh, will not always flood traffic out of all interfaces except the one from it received, and it is stopped. There is a there's an option which is enabled by default, which is known as RPF, reverse path forwarding. It is on our security guys. If you are watching this video, we call it as anti-spoofing as well, to ensure there are no routing loops. And finally, we have to configure this ACL, because unlike regular routing protocols like OSPF and AIGRP, these are regular routing protocols that use multicast addresses. And if I'm not wrong, OSPF use 224.0.0.6 and AIGRP use 224.0.0.10. They are being assigned. So if you're using those address ranges, you don't have to create an ACL. But since IETF haven't reserved till date, they haven't reserved any address range for get VPN. In that case, we have to come up with our own address range, and I've used 239.1.1.1. You would have used anything else, so it's not mandatory. Since it's not reserved, I have to create an ACL as well. We're going to use this ACL in our step number 3. Finally, the last but not the least, we have to create a GD OI group and identify the number. This number is very important because we have to give it the same number when we configure the clients, and the client will join this group through after they provide the right identification number. Server local. I think if you are aware of how get VPN is configured using unicast mode, this configuration you might be aware of most of the options. Over here, I've specified that I will be using this address range multi, which was nothing but the ACL. And the RSA keys, which will be used for our encryption. And IPsec VPN profile, where we have called out the IKE profile, which we created in our first step. And the IPv4 BABI, which was the crypto ACL in the first step. And finally, the IP address of the KS1, which was 11.11.11.1. Just to refresh your memory, this was a topology, and this was the IP address 11.11.11.1. The configuration is pretty standard and pretty simple, to be honest. I think after we can see step number 1, step number 2, and step number 3, options which we have configured in step number 1 and 2, finally they are called in step number 3, where we configure our GDOI configuration. Finally, the last step, so the second step which we need to configure is to configure our ISP setup. So the ISP, which is just lying in the middle, needs the configuration. Let's jump in and see what configuration needs to be pushed. Over here, we can see as pretty normal, we have to enable IP PIM dense mode on all the interfaces, and as well as this command. So this is nothing to do with get VPN. This is pretty standard, guys. So if you want to configure a multicast, you have to use IP PIM dense mode and IP multicast routing and the IP PIM dense mode over the interfaces. This is not a setting which is specific to get VPN. Finally, we're going to look into how to configure our clients. So the clients which we have been looking into so far, GM1 and GM2, what settings should be pushed. The settings will be identical on both GM1 and GM2. So I will only be looking for the configuration on GM1. But during the lab session, we will configure both GM1 and GM2. So over that time, you can basically have more overview. So now let's go ahead and configure the GMs. Yeah, so Over here, we can see the VPN configuration. So we have configured the phase 1 parameters and the phase 2 parameters. So we have defined a crypt transform set, and we call it as a cow set. And with the phase 1 parameters. So yeah, but remember the transform sets in group members, they are not assigned to an IPsec profile, unlike what we did for the KS, because uh, all these settings of IPsec profile will be pushed from the KS to the group members. Step number 2, enable the multicasting. The command remains pretty same. The only point with IGMP PIM with PIM dense mode is basically when the clients when it will be sending the multicast traffic from the client. So the groups need over the IP address 239.1.1.1. The case will send it over this address, and the group members need to join an IGMP group for 239.1.1.1. If we go back to the case configuration, what I did, I asked so I asked this case to send an IP, the multicast traffic out on host 239.1.1.1.1. But on the group members, I've asked all the groups to join this group 239.1.1.1. And finally, the last but not the least, the GDOI configuration. Nothing very complex. It's pretty simple over here, and we just added it to the IP address of the server with the identity number, and map the interface with the crypto map. So the configuration is very limited over the group members, because most of the configurations are basically pushed from the key server to the group members. So for the testing, what we can do, these are pretty simple commands. So you can ping your key server with the multicast IP, and you can expect the response from 13.1, 12.1, which are nothing but these addresses of the group members. So this is a very valid test to confirm whether your servers are responding to the group to the multicast addresses or not. And when we run the command GDOI group status, we can see whether on the key server to see whether the multicast is configured or not. Finally, we can even go back on the key server and see crypto VPN tunnel status and see whether our communication is happening properly or not. So I also run a packet capture previously to verify that when a user over the VPN is trying to send traffic across to each other, the traffic is encrypted. But if you remember, the IP address is 10.10.10.10 and 10.10.1 and 2, they are preserved. So outside the ESP header, you can see the original addresses are preserved when we try to ping the server. That's why we said that get VPNs can only be used over the private LAN or over the MPLS. So I hope you don't have any questions so far, and we will crack on with the lab session. So if you have any questions, guys, so feel free to put them up on the comment section. I will be there to help you out. And this link for the slides will be there in the description section. So review it and update your lab. So in this lab, what we have built up, let me bring up my lab. This is the key server, and I have done some bare minimum configuration so far on these servers, where I have configured just the IP addresses. If I go back and show it to you. So this is the IP address, only one IP address that is assigned to the outgoing interface. And And I'm using OSPF as a routing protocol just to advertise this network. And if I go back to the ISP router, it is configured with an IP with bare minimum configuration. And just with the routing. So nothing specific, only the IP addresses and the routing configuration is being performed so far. And no configuration is there even on the GM1 and GM2s. So let's start with the configuration to be pushed. And yep, so I will go into config T, and I will just go ahead and, for the sake of time, I will try to paste some configurations from the slide just to give us, rather than me copying it every time. So this is the case configuration which we suggested. Yeah. So yeah. Yeah, and then I'm going to define the peer addresses. Nice and easy. And finally, the crypto set. I won't define the mode tunnel because that's the default mode. And I will define an access control list. I won't change the name. Let me call it Barbie. And finally, assign create a new key profile and assign the transform set into the IPsec profile. That's pretty standard. That's what we usually do. And this configuration, this marks the completion of step 1 on case. And I go back on step 2. We just have to enable multicast configuration. This configuration is very standard. As I mentioned, you have to use it anywhere. It's not certain specific to get VPN. VPN1, and I have to enable PIM dense mode. So it's pretty standard. Nothing much has changed. And we have to define an access control list for get VPN to communicate with the multicast IP. I have already given the justification why we need it. Perfect. So this marks the completion of step number 2, where we have what we have done so far. We have just enabled the multicast configuration. Finally, we just have to start with our step number 3 configuration, where we have to define our GDOI group. Before we do that, let me create an RSA keys, which is a asymmetric algorithm. So one second, crypto key generate RSA. Sorry, RSA keys mod 1024. Perfect. And finally, it's pretty easy. We just have to go in there and create a new group, Dhruv, and define give a identity number, server local, and rekey address. For rekeying, we have asking it to use our not unicast. If I would have used, let me show it to you. So if I just go over there, created, and rekey. So yeah, so over here, so we have to identify that which address range we have to use it for rekey. So if we would have been using unicast, so in that case, we have to specify that the transport of that communication will happen over unicast. But in this case, we will use multi. That was defined in our access control list, and we have captured that in our previous slide as well. Sorry. Yeah, multi. Yeah. So I think I already explained what is the justification why we need to use IPv4 11.11.11.1, because that's the address of this case router. So that's how we basically configure and define which IP address will be used to communicate to the clients. So I hope till here everything is pretty much clear to you guys, and why and how we use it. So as I mentioned, if in case we would have used, oops, 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 oops. Let me go back. Okay, let me go back and show it one last point before we proceed further. So in our case, server local, yeah. So in our case, we are using as a multicast uh, mode of communication. That's why we have used Riki address as multi. But if in case, if in case we would have been used to unicast, so the only change, which is pretty simple, you just have to use unicast as a mechanism. So that's pretty easy. So we won't be covering these steps over here, because that's pretty out of scope from our session today. But yes, again, if you need a similar video for unicast, feel free to leave a comment and I will be there for you. That this basically marks the completion of the configuration on KS. Hey, and now we just have to log in on our ISP router. ISP routers needs to be configured with bare minimum configuration, and here we are. Yes, ISP. So ISP, the configuration is pretty simple. We just have to ensure that this router is configured to listen on multicast. So my P multicast, and it was, I think, routing. Yeah. Uh, yeah, is it right? Yeah. Yeah, that has to be right. Yeah. So this is so we just have to ensure that multicast is enabled. That, as I mentioned, that's something generic. It's not anything related to get VPN, and we have to enable it when we are using multicast over the iOS router. Finally, we just have to go into each and every interface DI1, and basically enable IP PIM dense mode. Job done. So that's something pretty easy, right? So that's the only configuration we did, and it changed, brought up and brought down the OSPF neighborship, which was already configured between all these four routers. So just want to show you what we have done so far on this router. I just went there and just added this IPPIM dense mode command in all three interface, gig interface 1, 2, and 3. And finally, I only enabled uh, the multicast configuration over the router. That's it. Job done. Finally, the last piece which we need to cover is to configure our group member routers. Yeah. So this router right now is only configured with very bare minimum configuration. So it is not configured with any get VPN settings. It's only configured with OSPF, settings, and the interface settings. As you can see, these settings are currently configured, and this router is actually pretty much empty. Yeah, and show IP in brief. Yeah, there is a loopback IP that is 10.2.2.2. Similarly, the settings are there for 10.1.1.1 as well. I will quickly go back into the slides and just copy and paste the contents just for saving some time. We have created some phase 1 parameters. And then we define the peer. In this case, we haven't used 0000, what we did for KS, because we know to which member it's supposed to communicate. And then finally, the IPsec profile, IPsec transform sets. This completes the step one for the group members. And I hope it's pretty much clear to everyone. And finally, in step 2, again, we have to enable the IP multicast settings. If you all just follow the slides, you can easily implement your changes as well. And I go into this interface. If I come out, and if you look into the topology, GM1, I go into interface 1. So if you remember, we, like in all the routers, we just enable IP PIM dense mode. Oops. Yeah, that's it. Job done. Yeah, I think I missed one step. I guess we also need to, if you remember in the slides, I also mentioned that these routers, since they are clients, they are supposed to join a group. I think the IGMP, it was join group. Yeah, 239.1.1.1. So they are now part of this group, and they have to respond to the multicast settings. So this basically cover up the step 2 for the changes we are going to do on the clients. And finally, the step 3 would be creating a GDOI group. So it should be crypto GDOI group, and we can name it as a group 1. Identity number. So identity number, which we use for case 1. Let me verify it. It was a 123. So I'm going to use identity number 123 over here, and followed by the server address, because it is not the local address, local server. It's not a case. So we have to point to it to the case from where it will download. Oops, did I missed V4? I guess IPv4. Yeah, okay, yeah. So IPv4, and finally we have to define the crypto maps, which crypto. Okay, sorry. Yeah, let me quickly copy it out from the slides. Okay. And finally, we have to assign this interface, this crypto map to the interface. We're going back to the topology just to make you all understand. Where is the topology? Yeah, and this is our PuTTY session interface 1, and we define crypto map, crypto. The name is pretty, it's not pretty efficient. Yeah, but at least it will work in the lab. So we define nothing yet. There's no typo. Yep. define it over here, and job done. So it says that, as you can see, it did completed the registration. Successful registration did happen for GM1. Similarly, we have to do the same settings on GM2. Let's quickly copy it out. Do we have a GM2 already opened? Let me verify. Yeah, where we have a GM2 session already running. Right now, it's only configured with the IP and OSPF configuration, nothing much. But now we have to quickly copy most of the configurations. Let's do it quickly, and we can verify the results. As I mentioned, the configuration on the clients will be pretty much same. What's that? That's ISP. Yeah. Mhm. Okay, so once we have defined the free VPN configuration, we just have to quickly enable multicasting as well. Routing. And quickly go into the interface for this. That's gig interface gig 1. We just have to enable IP PIM dense mode. Yeah, and and finally we also have to add this. Since it is again a client, you have to join a group. Take 239.1.1.1. Yeah, it should be right. And this completes step number 2 as well in our slide for the groups. I hope I have covered everything. Yep, I did. And finally, create a group configuration. I prefer copying it rather than typing, just for the sake of time. But yeah, but finally, and last but not the least, we have to assign this crypto map to an interface, which is in our case, it's again gig interface 1. Says 1, and I just had, so just the crypto map what we created in this previous step. We have to go here, crypto map, and copy the name of the crypto map in our case, which was crypto. And so as we can see, the comments, the registration again was successfully performed. So this basically concludes that our configurations for this multicast environment. If I go back on the case, you can see that the configuration for this group is multicast. And if I try to ping, oops. So if I go back on the slides and we see the verifications, this verification should work over here as well. So all the clients which are part of this multicast settings, they have to seems there is a problem. Let's just verify what's wrong. ISP show OSPF OSPF neighbors 10 to 1 and 2. I think it took some time that it's now slowly responding. I think the clients take some time in responding, and now we can see the both clients are responding to the multicast IP addresses. And when I do a ping, we can see that it is responding to the multicast address. Before we wrap up the session, I would also like you to review the PIM setting, because we actually pick up another topic, but which was PIM. So PIM is a multicast protocol, and we can even see show PIM. I think it was show IP PIM neighbors. Yeah. So we can see that the case did have a PIM neighborship, which is multicast configuration out from 11.11.1100, which is quite same to our topology. So, and if I even do a show IP, I think it was IPM root, M root, yeah. So if we can see, it's the dense mode, which is we are currently using. So I hope this multicast configuration is pretty clear to everyone, and I hope this session has been useful. And I want to thank you for viewing.